I'm going to guess that all of you were able to graph pretty easily, right? Not a problem. Naming your points. Go left or right first, up or down. And I'm also going to guess that most of you were pretty able to answer the questions on that page, at least up to the maybe last two, which I'm going to cover up, and let's go through these. You might not have exactly what I have, but why are A and B on opposite sides of the y-axis? And it has to do with their x-coordinate, right? Being plus or minus. And why are B and C on opposite sides of the x-axis? It has to do with their y-coordinates. And D is on the x, Y is on the, or sorry, E is on the y, and it has to do again with their x's and their y's, about our movement, how we move left or right, up or down. Was anybody able to associate, however, coordinate D with something that we would look at in terms of the unit circle? Anybody think they got this? Yeah. Beautiful. Why pi?
Because on the unit circle, like the left is pi.
Yeah, that spot on the left, if I could get rid of the numbers, but if I could draw a unit circle on here, again, not ignoring the 1, 2, 3, 4, 5, that would be the exact spot where pi would lie. Great. And then I'm guessing then if you guys were able to do that one, hopefully it makes sense that E would be where pi over 2 is. Those connections are going to be used when we are graphing polar coordinates. The position on the graph will have something to do with where the angle is and how it opens when we graph our polar coordinate. So then on the next page, oops, that's not the next page. Okay, on the next page, it asks you to plot the point 0.71, 0.71. And so if you plot it, here's 0.5, 0.6, 0.7, a little bit more. And it almost looks like 0.5, 0.6, 0.7, and a little bit more. It almost looks like it's right on the edge of that circle, kind of, doesn't it? A little bit? Does anybody see that? Or am I crazy? Okay. So if I were to draw this line here and draw a line from the origin and then actually finish off this triangle. So I'm drawing from the point down to the x-axis. That's what they asked me to do. And they asked me to draw a point from the origin out and then a line from the origin to the point. And I just created a right triangle. And in fact, I created a right triangle who has 0.71 for the x value and 0.71 for the y value. And so right triangle we just created. And what is the length of that hypotenuse? Anybody know the length of this guy right here? We can find it two ways. I see some single fingers up in the air, right? Yes?
0.71 squared plus 0.71 squared equals, I guess that's squared.
Yep. That hypotenuse squared. And when you do all of that work, and you just plug it in your calculator, if I have one, 0.71 squared times 0.71 squared. And then I get 0.2541, and I want to take the square root of that. Did I do it? Oh no, I didn't do it right. That's the problem. I need plus and not times. I thought that looked funny. Okay. And I get 1.0082, and when I take the square root of that, I end up with 1.004, or I could say my question mark or my hypotenuse is roughly 1. If you look at the picture, could you have told that anyways? What kind of circle is drawn here? A unit circle. How do I know? Because that radius ends here at 1. 1 whole. If this is 0.5, this would be 1 whole. That would be the point right here, 1 comma 0. So I could find that radius. It's about 1. That Pythagorean theorem concept will also be used when we talk about converting our coordinates into polar, our xy coordinates or our rectangular into polar. So on the next section, basically they ask you if r is any radius. Now we had a situation here where we had a unit circle that we were drawn, so 1 was pretty, we could find that just by looking at this. But if r is any radius, how can I find r? I can find it the same way that I found the hypotenuse in that other triangle, in this one. If I wasn't going to estimate, or if I didn't see it, I can just pull out the Pythagorean theorem. And so what I would plug in is x squared plus y squared equals r squared. But I don't want r squared, I want r. How do I get r alone? Square root of both sides. So I just take the square root of r squared, the square root of x squared plus y squared. How can I find r? Square root of x squared plus y squared. So I talked about r, and I hope that you guys read this kind of area in here. But if you didn't, I just want to point it out that x and y are how we write our rectangular coordinates. When we write a polar coordinate, we write it as r comma theta. R being a radius that moves out in the direction from the origin, and theta being an angle measure that moves us around and gives us a stopping point. So if r is the hypotenuse of any right triangle, when we convert a rectangular coordinate to a circular move, r is the hypotenuse, all we need is x squared plus y squared. That'll give us r squared. How about the angle? Well, again, I can draw this picture here, pull it out. If I have x and I have y and this is theta, and I want to figure out what theta is, I can use x and y, and because this is a right triangle, I can think about SOHCAHTOA. With respect to theta, y is which side? Opposite. And x is which side? Adjacent. And in SOHCAHTOA, which trig function uses opposite and adjacent? Tangent. Beautiful. So tangent of theta can be found by figuring out the ratio of opposite over adjacent, y over x. Now, when I find theta, I always think about theta in this term, okay? We've done this before. When does the tangent equal, or what angle has to be to make this equal when we're solving equations? In what quadrant would it have to be? But when we're thinking about solving mathematically, we can write it as the tangent inverse of y over x, or we can write it as the arctan of y over x. Those two things mean the same thing. But again, when I talk through it, I'm going to think of theta in terms of solving an equation. Why? Because we're going to be using only families in our conversions today. We'll be using things that we recognize. 1/2, square root of 3 over 2, 1, all of those things that we have seen before. So when we think about solving or converting, we will use this form. So let's convert. I'm going to use these formulas to find this. Well, we already did the top one. We did the square root of x squared plus y squared. But before I go in and find theta, I want you to think about the families and axes that we know. Pi over 3, pi over 4, pi over 6. 0 pi, whole pi, pi over 2, 3 pi over 2. In which family is the x and the y the same? Pi over 4. So what theta are we probably going to end up with here? Pi over 4. Let's go ahead and do the work. So again, we already did that up one, so I would do my r is equal to the square root of 0.71 squared plus 0.71 squared. That's x squared plus y squared. So my r is equal to the square root of what I got when I plugged that in, and it was 1.0082. And when I took the square root, I got the point roughly 1.00 something, but I'm going to keep it at 1. So again, second square root of that value, and I get 1.004, close enough to 1 for me. So if my xy coordinate is 0.71, 0.71, that's my xy coordinate, then my r theta coordinate has a radius of 1. And now let's find our theta. So the tangent of theta can be found by putting the y coordinate, here's x, here's y, the y coordinate, 0.71 over 0.71. And then solving for that. So when I simplify 0.71 over 0.71, same thing over itself, I ask myself, when is the tangent 1? When is the y coordinate the same as the x coordinate? And you guys already answered that for me. That is in the pi over 4 family. But remember when we did this, we talked about another thing, not just when is it 1, but because there's no sign in front of 1, I had to also ask, when is it positive? And I still have to think about that. So it's pi over 4 in the first, and where else? Third. Excellent memory, you guys. First and third. So my possible options are either pi over 4 or 5 pi over 4. That's my first and my third. Well, how do I decide which one? Go back to the original point and figure out what quadrant this one falls in. Where is 0.71, 0.71? First quadrant. So my answer is going to be the first quadrant angle. Cross out the other one. I can go ahead and put that in. All right? So we're going to be converting again a regular, rectangular, normal point into a polar coordinate. Any questions so far? Okay. There we go, 2, 2. Hey, right away, what family? 2, 2. What's my angle going to be? It's going to be in a pi over 4 family again. How do I know that? X and the y are the same. Just like if I fell on an axis, I should be able to recognize that right away too. We'll get to that. All right. I know this is pi over 4 family. Let's take this again. Here is my x and my y. Let's convert this into my r and my theta. So we'll start with r. R is the square root of x squared plus y squared. Some of us, again, have those nice calculators that do this conversion for us nicely. I do want you to keep it exact. So if you can simplify this radical, please simplify it. Those of you who have those beautiful calculators that take the work out of it for you, lucky you. The rest of us are going to have to break this down. 8, I start with the smallest number, more than 1, that goes into 8, and that's 2. And I keep going until I can't go anymore. And then I pair them off. For every 1 pair, 1 goes out. Whatever doesn't have a pair has to stay in. There are other ways to simplify radicals, but I believe when we first started, we talked about it this way, okay? It's been a while, and if we need to review it, just let me know. We can go through that. So that gives me my r, 2 times the square root of 2. And now I'll do my theta. So the tangent of theta is found by taking the y value over the x, or again, I'm in the same boat I was before, the tangent is 1. The tangent is 1 in the pi over 4 family, and it is 1 in the first and the third. So I have pi over 4 or 5 pi over 4. Kind of a duplicate from our last problem. Same thing we did when we were solving. We're going to talk our way through it. When does this happen? I like when it's 1. I like the pi over 4 family, nice and easy to work with. When it's not, when it's undefined, when it's 0, when it's things like that, I have to take a different approach and maybe have to simplify it differently. But right now I know which one of these two is going to be the answer. Definitely pi over 4. Are you magic? How do you know? Where is this guy? First quadrant. What answer am I going to use? The first quadrant answer. We're not afraid of a couple radicals, are we? In fact, we've seen a whole lot of the square root of 3 shown up in our life this first semester together, actually, term 3 together. So I'm not afraid. When I see square root of 3, I already can think this has to be pi over 3 or pi over 6. It has to be, because that's where the square root of 3 shows up. If you were to take a guess, which one do you think it is? Pi over 3 or pi over 6? Anybody say pi over 3? Anybody say pi over 6? Anybody too afraid to answer because they're just not sure? You guys quit talking to me. What's going on? Okay. This square root of 3 is in the y position. And if I back up to pi over 3, which is 1/2 square root of 3 over 2, and pi over 6, which is square root of 3 over 2, 1/2, which one has the square root of 3 in the pi position? Pi over 6, yeah. So before I even start, I think about those things. This is a first quadrant, most likely pi over 6 angle. I just need to figure out the radius. And so I'm going to go with my radius. It is equal to the square root of 1 squared plus the square root of 3 squared, which is the square root of 1 plus 3, which is the square root of 4, which beautifully is plus or minus 2. It is plus or minus 2. And I could actually use negative 2 if I wanted to, but that's for tomorrow, like direction-wise. We'll talk more about that. Right now, let's stick with only the positives. So if this is my xy coordinate, my r theta coordinate is 2 comma something. Like I said, I am already very confident that this is the pi over 6 family just because of the location of the square root of 3. But to double check and make sure, I'm going to go ahead and do, sorry, pi over 3 family. Did I say pi over 6 family? I meant pi over 3. I said it before too, didn't I? Ugh, why don't you guys stop me? Say something. Yell at me. All right, pi over 3 family I meant. And again, let's go back up here. I didn't mean to mess you up. Pi over 3 family. Sorry about that. I'm going to do the tangent of theta is found by taking the y over the x. So I want to figure out when the tangent is the square root of 3. And again, thinking about that, we've seen it before, but sometimes maybe we need to refresh our memories. It will either happen when I put the square root of 3 over 2 over 1/2, or it'll happen when I put 1/2 over the square root of 3 over 2. And I'm going with this first guy. So that's when the sine is the square root of 3 over 2 and the cosine is 1/2. And like we said before, that is the pi over 3 family. I said it correctly this time, thank you. All right. And it is positive in the first and in the third. Yep, first and third. Almost wrote fourth there. Jeez Louise. Okay. First and the third. I can't believe you guys keep coming back to all these mistakes. First and third. So that would be pi over 3 and 4 pi over 3. And I go back and find out what quadrant I'm in, and this guy is in which quadrant? First quadrant. So I'm going to do my first quadrant answer. Pi over 3 is the one that goes in. All right. Spicing things up a little bit. On this next one, I am not in a quadrant. I am where? On an axis. And in fact, where is this point going to fall if I were to graph it? Pi over 2. Great. There's theta. That's it. That's all I have to do. I've got my theta. It's on an axis because when I plot it, I know that's where it is, and that's exactly where pi over 2 falls. If it landed here, it would be pi. If it landed down here, it would be 3 pi over 2. If it landed at the beginning, it would be 0 pi. So there I am. Anybody bothered by that? Less work, right? Let's find r. R is the square root of x squared plus y squared, 0 plus 9, square root of 9. Again, it could be plus or minus 3, but if I do minus 3, it changes the size of my angle, and therefore would change my theta answer. And so I'm going to keep it positive for right now. We'll get into how it works when they're negatives. So what I'd like you to do, please, I'm going to pause this, and I'm going to let you kind of work through these 4 and 5 and see if you can connect them. I want you to determine if this given point is accurately converted here. All right, so take what we learned and go through that, and then we'll go through those answers shortly. 5, same thing. Determine if that given point is accurately converted there. So again, this is a little bit tough, hard to kind of wrap our heads around, and even more than that, harder to plug in our calculator accurately. So please make sure if you're using your calculator for a problem like this, that you put parentheses around the whole number before you square it. Just like if it's a negative, you want to do the same thing. Put parentheses around the whole number before you square it. Otherwise, the calculator really doesn't know what to do. So I have to square 2, that's 4. I square the square root of 2, that's 2. 4 times 2 is 8, so I end up getting 8 plus 8, square root of 16. I'm going to keep it positive, that's 4. So far, so good. And even without having to go through this process, you should have already guessed that this is a pi over 4 family in the first quadrant, just because the x and the y are the same, and they're both positive and in the first quadrant. So yes, that one worked. How come the next one didn't? You could stop right away by graphing. Yes?
Because it's, for this, it's on the x graph, or x axis, and for the other one, it's on the y axis.
Exactly, yeah. If I were to graph pi over 2, or find where pi over 2 is, that one is up on the top. That is on the y-axis. If I graph 0 pi, or if I plot this point, it actually lands over here at 0 pi. So when I write my correct point, I can write it as either 2 comma 0, which is the way it's mostly written, which is weird because it absolutely matches this first one, and you might look at it and go, how do I know if it's polar or if it's rectangular? Well, you know it's polar because they'll say the polar coordinate that you have, okay? But sometimes I write it as 0 pi just because that makes it, converts it into a polar coordinate visually, all right? So far we've done all first quadrant, so let's put our hand at some other quadrants, and again, kind of go through the same thing, all right? Same process. We are afraid of fractions sometimes, but don't be. And again, once you get a little bit more comfortable doing this, you can find the radius just by looking at the problem. For example, do you recognize these points? Where did we see them? On the unit circle. What's the radius of a unit circle? 1. What's the radius of this one going to be? 1. It has to be, because this one is exactly on the unit circle. So I already know without doing any work my radius is 1. Let's say I forgot that. Let's say I'm like, oh man, I'm never going to remember that. I can find r the same way. I just have to work with squaring the fractions. Make sure you put your negatives in the parenthesis. And what I have here is the square root of 1/4 plus 3/4, which is the square root of 4/4, which is the square root of 1, which is 1. And so if you forget, you can always use that method as well. All right, without even setting up my tangent equation, what family am I looking at? Pi over 3. And I know that, and I said it right finally, pi over 3, because back when we talked about this, pi over 3 is 1/2 times the square root of 3 over 2. So my square root of 3 is in the right position. So this is the pi over 3 family. So the tangent of theta has to be equal to negative square root of 3 over 2 over negative 1/2, which is tangent of theta is the square root of 3. And we know that that is positive in the first quadrant and in the third quadrant. And in the first quadrant, that's pi over 3. In the third quadrant is 4 pi over 3. Which one do I pick? The 4 pi over 3. How do I know? This is a third quadrant point. So really, a lot of it is kind of recognizing again and talking yourself through. Let's do our next one. Where does this point fall? At pi. Beautiful. Right there's pi. What is my theta without even thinking? Pi. Because when I plot that point, it falls where pi is. That's it. I can go through the process and I can set it up. This is when the tangent is 0. But why put yourself through that, especially when it's on the axes? Waste of time. Okay? Now let's talk about the radius. Can anybody guess the radius right away? 5. Why? By looking at it, do you know it's 5? Because the X says it's 5 basically, but it's 5 times what negative 1, 0 was. It's 5 times that amount. But again, if you're not sure, go through and do my r. It is the square root of x squared plus y squared, which is the square root of 25 plus 0, which is the square root of 25, which is, keep it the positive value. Again, it can be the negative value. We'll talk more about how we do that tomorrow. Not tomorrow. What am I talking about? Again, crazy talk. When we meet again. But this is my angle, or my polar coordinate. One more. Can you guess the family immediately? Yes. Which one? Pi over 4 family. Can you guess which of the pi over 4s this one is? What quadrant? This is a 4th quadrant pi over 4. 4th quadrant pi over 4 is 7 pi over 4. Beautiful job, you guys. Awesome. Is the radius 10? Can I make that guess that it's 10? No. It doesn't work like this last one did, because I'm comparing it to 1 and negative 1. This I'm comparing to the square root of 2 over 2, square root of 2 over 2. So sometimes I might be able to see it. Other times, I'm gonna have to depend on this. So this is 10 squared plus negative 10 squared, which is 100 plus 100, or the square root of 200. Again, some of us have calculators that'll break that down for us. The rest of us will have to break it down ourselves. Divide by 2, divide by 2, divide by 2. 2 doesn't go in, 3 doesn't go in, 5 does, and I work my way through up like that. And then I take out the pairs. I have a pair of 2s, I have a pair of 5s. So this is 2 times 5 on the outside. Take out 1 for every pair. The loner that's left here goes on the inside and stays as is. So this is 10 times the square root of 2. 10 times the square root of 2 is my R coordinate. Okay? All right. How do you guys feel about polar coordinates so far? Okay? Hopefully not so bad.